totally new to us. Still after still
Yeah, correct. But it's interesting
hypothesis
if you
testing.
see these things. It's very interesting. It's
Yes, sir.
very useful in real life world. Okay, so I would suggest to focus more on it and just not to just consider. I mean, do not consider just to complete the exam and all. That's also important. But thing is, I would suggest to do something in depth, right? To learn something in depth so that you should get something. Okay, all right. So maybe before starting of the slides, questions, before starting discussion of the questions, I would like to discuss something to all of you. I mean, some basic ideas and all. Then we will proceed further. Okay.
Yes, sir.
Okay. So can you tell me what is the hypothesis testing? What do you mean by hypothesis testing? I want to hear in layman talk.
So basically, it means that the evidence which we are getting is true or not for the some. If for example, if the evidence is for 10,000 data,
Hmm.
and if we want to know that is this correct for 1,000 data or not.
Okay,
So basically,
what do you mean by hypothesis? First of all,
not sure.
Sir, actually in layman words, we can say that the hypothesis is a process. एक प्रक्रिया है जो कि सर आपको एक पॉपुलेशन में से कोई अगर कंडीशन दिया हुआ हो वो सत्य है या फिर सत्य नहीं है ये निकालने के लिए हम उसको क्या करते हैं व्यवहार करते हैं उसमें
okay. Anybody else? Any thought? What do you mean by hypothesis testing? Like suppose someone will ask you, then how will you explain? I mean, in general.
Rules which were used.
Okay.
So hypothesis is something statement which not proven yet.
Something assumption, correct? Some
Yes, sir.
assumption. Okay, let me
With
write something. Let me
without
write
facts.
correct. Let me write something. Suppose I'm just writing a situation. Imagine.
sir we can say that it's a kind of educational guess we can say
Okay, let me write a situation. Okay, you will tell me. So suppose imagine you are a let's say quality control manager. Okay, in a chocolate factory. Suppose. Okay. Now the thing is, your company claims that each chocolate bar weighs exactly 100 grams on average. Okay, this is the claim from your company side. Okay, understood? I mean, usually we can say, right, this kind of claims. But suppose customers have, you know, started complaining about the variations in weight. Okay, means your claim is exactly 100 grams, but customer says there are it's not exact 100. So they have started regarding the complaining regarding the variations in weights. Okay, now main question is, how can you verify, okay, if your company's claim holds? Okay, this is the main question, and this is where hypothesis testing comes in. Okay, so basically the thing is, why what is the hypothesis testing? So if you see the word, so hypothesis is just a assumption, or you can say it's a claim or assumption. That is something hypothesis, that's not, that is something assumption. And what you are going to do, you are going to test that assumption. Okay, so imagine this scenario. Okay, so your company claims that the weight of each chocolate is exactly 100 gram, but on an average, right? But customers have started complaining. I mean, there are variations in the weight, but main question is, how can you verify if your company's claims hold or not? Okay, so this is where your hypothesis testing comes into the picture. So another thing, another scenario, you can think something like, let's say, there is a soft drink company that claims its 500 ml bottles contain exactly 500 ml of soda, let's say. Okay, and there is a customer who suspects that the bottle contains less than 500 ml. Now what is the case? Then how will you proceed? How will you verify? How can you verify your uh, claim, right? Then what you will do, you will take a sample, and you will see, let's say we are talking about on an average, then you will observe the weight of chocolates, okay, based on those sample. And then you will proceed the for you will proceed your procedure and all, how to, I mean, to check whether your claim is true or not. Okay, is the overall idea clear? So basically hypothesis testing, if you will talk about in technical terms, so it's a statistical method, okay, which is used to make decisions, or you can say it's make by making decisions or making inference about a population based on the sample data. Okay, so based on sample data, you are going to check your claim. Okay, the thing is, it will help you to determine whether your assumption, right, assumption, or whether your hypothesis about the population is true or false. Is the rough idea okay? Yes, no?
Yes, sir.
Okay.
Yes, sir.
So the thing is, there are uh, two types of error. Okay, which okay, so there are two types of error which can occur during this procedures. Okay, first one is called type 1 error. Okay, so we'll come to that type 2 error. So I will discuss the type 1 error for now, just to give you one idea. So what is the type 1 error?
Reject H naught when H naught
H
is true.
Right,
is read.
so I'm rejecting H naught when H naught is true. So H naught is nothing but null hypothesis. Okay, okay, so what is this? So basically this is sometimes it's called false positive. Okay, don't worry about this term. If you are not getting false positive, it will be clear in a minute. So type 1 error, and there are two kind of error, type 1 error and type 2 error. Let's focus on type 1 error first of all. So see, this type 1 error is called false positive. Actually it represents the, basically this, okay, first of all let me tell you, define something alpha. Alpha is what? This is called probability of making type 1 error. Okay, and what is the type 1 error? Probability that reject H naught given that H naught is true. Okay, so what is this level of significance? So basically it represents the risk of making this error. Okay, so you are going with some kind of risk. Okay, it represents, okay, the risk of making a type 1 error. Okay, so basically it will represents the risk. So what do you mean by risk? Suppose, see, usually you have seen in some questions and all, we are taking alpha as a 0.05, that means 5%, right? So what do you mean by this 5%? What can you conclude this 5%?
A 5% error.
Okay, basically I will say there is a chance of there is a 5% chance, okay, of type 1 error. Okay, this is the meaning. Now, what is the meaning of this line? This means this. What is the meaning of this? Means 5 out of 100,
100.
right?
Yes.
Let's say I'm talking about in terms of COVID-19 patient, right? Okay, let me create a scenario. Okay, suppose I'm saying, let's take a situation of medical testing. Okay, and our hypothesis is the patient does not have COVID-19. Okay, and what will be the alternative? The patient has COVID-19. Okay, now if by considering this scenario, what is the meaning of this? This means 5 out of 100 healthy people might incorrectly test positive for COVID-19. Are you getting now? So this is
Yes, sir.
see what alpha represents. Alpha represents the risk of making a type 1 error. And what is the type 1 error? It's a false positive. Means if you are, what is the meaning of this 5%? So 5 out of healthy people, okay, they might incorrectly test positive for COVID-19. Means they didn't had the COVID-19, but it's incorrect. It's a false positive. Okay, they incorrectly test positive. Means their report comes positive, which is incorrect. At least for 5 people out of 100. Are you getting? Now, if you will say alpha is 0.01, that means 1%. So what do you mean by this? That means only 1 in 100 healthy people will get a false positive. I mean, basically incorrectly test positive for COVID-19. Yes or no?
Yes, sir.
Okay, so you are going with some kind of risk. So usually we take this 5% is common, but we take alpha as 1% only. Which see okay, can you tell me when you will prefer to take alpha as 1%? In what kind of situation?
So the severity of the scenario, say for
Scenario,
example.
right? When you have to take strict decision,
Yes, yes,
right?
exactly.
So for example, let's say medical studies,
Yes,
correct?
correct.
Yes or no?
While releasing a drug into the market, then
Correct. So because see you see in this scenario, if you see in the above scenario, you are going with the 5% error, right? But here you what is the meaning of this? Only 1 out of 100 people, 100 healthy people, you know, I mean they might incorrectly test positive. Okay, idea is clear for COVID-19. Okay, and what is the beta? There is another kind of error. Beta is probability of making type 2 error. So what is the type 2 error? Tell me. Accept H naught when H is true. Okay, let me consider one scenario and you have to tell me which one is the type 1 error and type 2, and then I will proceed further. Okay. Suppose I'm saying there is a item, or you can say product, which is manufactured by a company. Okay, and there is something called probability that you have accepted the reject an item of good quality given that it is of good quality. Okay, and another scenario is probability that accept an item of good quality given that it is of bad quality. Now tell me which one is the alpha and which one is the beta and why.
Sir, first one is the alpha.
Okay,
Be- because in this we are rejecting an good quality product.
rejecting H naught when it is true, right?
Yes.
And what is this is the beta,
Beta.
means probability of accepting H naught when it is of
false.
bad quality, right? So okay, now I will take a name. I mean, name or word you can say. Basically, which one is the producer's risk and which one is the consumer's risk? This is not taught in Stashu, but I'm just giving you some idea. Which one would you consider as a producer? It should be producer's risk or it should be consumer's risk?
Beta will be producer risk.
Just think a bit again.
Beta is
It's
consumer risk,
consumer risk.
and
Consumer risk.
It's a producer's risk, right?
Alpha
Yes,
is
sir.
Because the thing is, your item was good quality, but customers rejected. It's your risk. Okay. And this is the consumer's risk. Yes or no?
Yes,
I
sir.
mean, you have accepted a product which was of bad quality. Correct?
yes, sir.
Okay. So this is there are some tests, right tail test, left tail test. So I think those we have discussed. If you want, we can discuss later also, because anyway we have to discuss the solve with the slides. Okay, so let's start. So this is the peer day code. Okay, so everyone please join this. I hope everyone is aware how to join this. So let me repeat the procedure. So you have to enter joinpd.com in your browser, but whatever you have, either in phone, your phone or laptop, and then it will ask to enter a code, which is code is WCNCHH. Okay, so please join it fast. I would request to everyone join it fast so that we can solve some questions from the slides. Okay. So 9 of you have joined. I would request to everyone, please join it so that we can start. So we'll wait till okay. So is there any class for tomorrow session or is it fine? Tomorrow is did you check your calendar?
Fine,
There
sir.
is.
Tomorrow we have one session only at that time. I don't know if someone is having
Sir,
Python.
tomorrow which session, sir?
So there is one revision session for week 9 and 10.
Yes, sir. Tomorrow is.
Okay, so I just wanted to cross check with all of you. Is there any?
No, sir. I think no, sir. No classes.
Okay, okay, great then. Okay, so I
Will
will,
you take the tomorrow
we'll
session?
wait for 2 minutes, then we'll start this session. Yeah, sorry, someone is saying something.
Sir, will you take the tomorrow's session?
No,
Most
sir. On Wednesday, every class is almost suspended, so you can take the session. No problem.
okay, fine, all right, no problem.
Sir, tomorrow are you going to take the session, sir?
Most probably yes.
Okay.
So as per the availability,
Okay.
I think I will be there. I'm not sure about any emergency situation, but yeah, I will be there. So 18 of you have joined. Okay, so I would require. I think. What about others? You don't want to join or what? please join it fast so that we can start.
Excuse me, sir.
Yes.
Sir, when will be the all the slides open in joinpd.com?
Sorry. Can you come again?
Sir, when will all the slides open on joinpd.com? There is showing only one slide. Week 11 graded. Solve with us.
I'm not getting your doubt.
Then the
It is for all. It is for all. You just have to wait. When I switch the slides, you will get update.
Okay, okay. Thank you.
yes.
Okay, I think she's asking about that question. Okay, just wait. Okay, so I would request
Okay, sir.
everyone, please repeat. Please join it. Let me repeat the procedure. So what you have to do, just either in your phone or laptop, just enter this joinpd.com in the browser, and then it will ask to enter a code. So code is WCNCHH. Okay, so please join it fast, and so that we can start. Listen, okay. So let me start anyway. The code you can see on my screen, top right, top side corner. Okay, right side corner. So this is about week 11. So the very first question is, so it's given, situation is given to you. Suppose x follows normal mu comma 4, and for n equal to 100 IID samples of x, the observed sample mean is 11.8. And the question is, what conclusion would a Z test reach if the null hypothesis assumes mu is equal to 10, and alternative is mu is not equal to 10. So this abject value is given to you. Similarly, it will be given in end-term exam also, along with the formula sheet. So main question is, you have to choose the correct options from the following. So what you have to do, you have to write the option number. Let's say first is correct, then you will write 1. And suppose 3 is correct, you will write 1 comma 3 comma something like that. Okay. So I'm going to give you 3 minutes for this question. Please do let me know if you need extra time. Okay.
Sir, is the answer is so 2589?
See, we need to check what is the answer. First of all, just attempt question from your end.
So allow 3 more minutes.
Okay, anybody? Do you need extra time?
1 minute, sir.
Okay, then let me see the responses from your end. So 2258, 2589, 24159, 2489. Okay, variations are there. No questions. Okay, anyway, so first of all, which test statistics is going to be used for this question?
Two-sided z-test.
It's a sample mean or sample? It's a sample mean, right?
Yes, sir. Sample.
Because your hypothesis is all about your mean only. I mean, you are
Yes.
going to test for mean. Okay. So what you can do, so whatever the things given to you, just write those things. Okay. So the first question is, okay. So first question, what is the given situation to us? X follows normal mu comma 4, correct? And what is the another situation? There are 100 IID samples from this X. So basically X1, X2, let's say this X100, this all are IID from X. Okay, this is the situation. And they have collected the 100 IID samples, and from there, what is the sample mean they have observed? 11.8. And what is the hypothesis first of all? What are the things given to us? We have been given alpha. Alpha is what? Usually we take 5%. Yes or no? And this is also given to us. Yes?
Mu.
No.
Null hypothesis. Null mu.
And what are another things given to us? Mu, right?
Yeah.
So mu is h naught is mu is equal to 10, and alternative is mu is not equal to 10. So what is this? This is two-tailed test.
Yes, sir.
Okay. So one tail test means either mu will be greater than something or mu will be less than something, right? So this is right tail test and this is left tail test. Okay. So what is this two tail test and all? Let me draw a graph to give you a brief idea. So suppose this is normal curve. It should be symmetric. My drawing is bad here. So this is mu. Okay. And suppose this is some value, let's say C, and this is suppose some value, this is minus C. Okay. So what you can do, this is the region and this is the region. So in two-tailed test, this is the rejection region. This is the rejection region. Yes or no? If your values will lie here, you will reject, or here, right? Means, see, if okay, how will you define your test here? Means when you will reject your H naught.
When X bar is greater than C.
Just think of it. This is two-tailed test, not a right-tailed test. So you will reject H naught if absolute difference between X bar minus mu is greater than something.
Greater than C.
Okay. Now what is this? What is the meaning of this? This part I can write X bar minus mu greater than some C, or X bar minus mu greater less than minus C. Yes or no?
Yeah, you can.
And what is this? What is meaning of this? X bar is greater than mu plus C, or X bar is
greater than mu.
Less than mu minus C. This is what this graph tells you basically. Okay. So from here you can get some idea. Basically, you can, this is mu minus mu or mu plus C. See, values you can adjust this according to the critical value. So what I'm trying to explain you.
But sir, one thing in the second condition, if you multiply with minus both sides, the sign will be from less than to greater than. But before x, there will be coming as minus x plus.
That is a mathematical thing. We knew there is no need to worry about those things. What we have to concern here, whether your x bar is greater than mu plus c or x bar is mu minus c. Okay. If it is one tail test, then what you will do, whether your x bar is greater than c if right tail test and x bar is less than some c if left tail test. Right? Is this clear?
Excuse me, sir.
Hmm.
Sir, just to clarify, here we took modulus of sample mean minus mu, right? So this is due to it is not equal to 10, right? That's why we are taking modulus.
Correct.
Okay.
Because we are not equal to means what? You don't know whether it's the right tail test or left tail test, right? Mu is not equal to 10 means mu can be greater than 10 or less than some value, right? Okay. So that's why we are going with the two-sided test. Okay. In one-sided test, in right tail test, where your critical region will be there, here, right? And in left tail test, your critical region will be here. Understood?
Yes, sir.
Okay.
Thank
Now
you.
this is given to you, and tell me if for this x, so for 100 sample, for 100, basically for x1, x2, x100. Okay. Tell me what will be your what will be your distribution of x bar? Yeah.
Normal mu comma 4 by 100.
This is normal mu comma sigma square by n. So mu, what is the sigma square?
4 by
comma. Okay. I'm assuming this is clear to everyone. Okay. Now what we have to do, the next step is you have to start with your probability of type 1 error. So alpha is probability of type 1 error. Okay. So by this, what we will do, we will try to find the value of c and then decide whether we have to reject or not. Now next task is probability of type 1 error. What is this? Accept, reject H0 when H0 is true. And what is the alpha? Alpha usually we take 0.05, right? And when you will reject your H0 from the
x bar minus mu greater than c.
X bar minus mu is greater than some c. What is the H0? H0 is mu. Now what is the usual procedure? Okay. So what we will do, we will convert this part into standard normal. Yes or no? That's what we are doing. Yes, no? Are you getting? So to convert standard normal, if you see, what do you need? You need x bar minus mu. Basically, you need x bar minus expected value of x bar divided by standard deviation of x bar.
Yes.
Right? This means what? X bar minus mu divided by 2 by 10.
Yes, sir.
Now, if you see here, mu is already subtracted, correct? Then what we have to do? We have to just divide by 2 by 10, yes or no?
And sir, the value of mu is already given, na? 4.
Mu is 4?
Oh, sorry, mu.
Mu is 10. So, see,
sigma square.
Then you will substitute 10 here. That's not impact, right? So, this will be C divided by 2 by 10?
Yes, sir.
Yes.
Correct? Because see, there is no need to subtract C minus mu because it's already there, right? Now, if you see what is this, this will become Z greater than C divided by 2 by 10. Basically, this will become
5C.
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 So, probability mod of Z greater than 5 times of C.
Yes.
Okay. Now, what you can write? So, this part I can write probability Z greater than 5C or Z less than minus 5C.
Yes, sir.
Correct? Now, next task is, okay, this part I can write probability Z greater than 5C plus probability Z less than minus 5C.
Yes, sir.
Would you agree with me now? So, if you see in the question, what is the value given to us? Fz of minus 1.96 is given to us. Okay, that means, okay, for this, if you see, this is something already we have discussed. Suppose this is mean is 0, this is standard normal curve. If this is minus A and let's say this is A, so due to symmetricity property, probability Z greater than A, this is same as probability Z less than minus A or not in the normal standard
Yes,
normal.
sir.
By using this property, can I say probability Z is greater than 5C? This is same as probability Z less than minus 5C. Would you agree with me?
Yes, sir.
Correct.
So this part I can replace with probability z less than minus 5c plus probability z less than minus 5c. So far so good.
Two times. Yes, sir.
Yes, sir.
Yeah, 2 times. I will come to that part. Okay. So this will be 2 times probability z less than minus 5c, and this is 0.05.
0.05.
Now, this will become 0.025 because it will divide with 2,
Yes.
and this is probability z less than minus 5c.
So,
And
sir, we can show the inverse of.
I will come to that part. Don't worry. So this is this part. Now, from the question, there is one hint fz of minus 1.96. So fz of minus 1.96 is 0.025, right?
Yes,
So
sir.
from here, what you can observe, fz of minus 5c, this is value of what? Fz of minus 1.96.
96.
So this means what? Can I say minus 5c is same as minus 1.96?
96.
So this means what? We have to do c equal to 1.96 divided by 5. What is the value?
0.392.
0.392. Now, what was the test? If you see, the test was you will reject H naught if absolute difference is x bar minus mu is greater than some c, right? And what is the absolute difference first of all? Okay, you have to check. So what is the x bar? 11.8?
Yes, sir.
No, that is given in question only. And what is the mu? Mu is 10. Yes, no?
Yes, sir.
What is the value? 1.8.
1.8.
Yes, sir.
This is
Greater
greater than C,
Yes, sir.
0.392. This means what?
Reject.
You will reject your answer. Is this okay? So
Yes, sir.
option number 2, option number 5, because it's two-sided jet test, and option number
9.
9. What about option number 7 and 8? You can cross check. Okay, I'm not going to solve for that. Okay, basically you can solve for this part when alpha is 10%, and then you can proceed. Procedure is the same. Okay, is the idea clear?
Excuse me, sir.
Yes, sir.
Sir, please explain first option.
So first option is not correct. It says test statistic use is p, right? You didn't we didn't use test p as a test statistic. What is our test statistic? It's x bar minus mu, right? That is sample mean. Okay.
Okay. Okay, sir.
Okay, if this is the clear, then yeah, this is the same part, calculation part, which I did in my PDF. Okay, so you can see. Yeah, so 0.392 was the correct value. Yeah, so this is the we will reject that now. Now the next question is,
Sir,
so whether
the calculation which you are doing today, can you share with us the PDF?
yeah, so I think we can say after the end of the session.
Okay.
So first, there is one part of question number 2. It says it is claimed that lifetime of light bulbs are normally distributed with mean of 100 hours and a standard deviation of 2 hours. We wish to test the hypothesis. Okay, so there is hypothesis. What is the claim? Mu is equal to 100, and what is the alternative? Mu is not equal to 100. Okay, what is sample size of this part is 9 only. So you have to find the significance level if the acceptance region is this 98.5 less than or equal to x bar less than or equal to 101.5. First of all, tell me, you need rejection region, right?
Yes, sir.
So this is okay. You have to think a bit here. So this is two-tail test. Okay. So in two-tail test, if you see, this is the rejection region, and this is the rejection region. Yes or no? Suppose this is value A and this is value B. Okay, if your x bar or critical value will lie after this B, you will reject, and before A you will reject. Yes or no? What is the acceptance region? This part, this dotted part, right? Means when you will accept A less or equal to, let's say we are talking about in terms of mean, It will be A lesser equal to X bar lesser equal to B. This is your acceptance region, right? Now, in this question, you have to find the rejection region, because and only I mean only after that you have to you can calculate the alpha. Okay. So I'm going to give you 3 minutes. Please let me know if you need extra time. So do you need extra time?
Yes, sir.
3 minutes?
Yes, sir.
Yes.
So I have received very few responses. So you are still trying? Do you need extra time limit?
Yes, sir. Still trying. Give us 1 more minute, sir.
Okay, okay, all right, no problem.
So can I give 1 minute more, please?
So do you need extra time limit or is this fine?
Done, sir.
Okay. Okay, 0.9 yes, I don't know, someone has entered 4.5, 0.024, 0. Okay, let's see. Okay, so first of all, let's try to write the situations, what are the given. So see, while solving any problem, just try to write what are the things given to you in the question. And by the time it will be clear what are the things you have to calculate and all. So let's say X represents the lifetime of the light bulb, okay? Okay. In the question, it's also given that if what is the mean time with 100 hours and standard deviation of 2 hours. So this means normal 0, 4 because I'm writing variance here.
Yes, sir.
Okay. And what is the sample size? 9 only. And what is the mu? I mean H naught, mu is equal to 100. And against the alternative is mu is not equal to 100. First of all, by this time it is clear this is two-tailed test. Okay. You are saying it's not equal to it. May be greater than some value, it's maybe less than some value. So question is you have to calculate the alpha, that is significance level. So what is the significance level? Alpha is probability that rejecting H naught if H naught is true. But in the question itself, you have been given the acceptance region. That what is this acceptance region? So acceptance region is X bar will lie between 98.5 and what is that? 101.5, right? This is acceptance region. Okay, so that means this is your 98.5 and this is your 101.5. Okay, so this is your acceptance region. Yes or no? What will be your rejection region? When X bar will be more than this 101.5 and X bar is less than this 98.5. Would you agree with me? Only then you will reject your H naught. So this will be you'll X bar will be greater than 101.5 or X bar is less than 98.5. Then you will reject your H naught and H naught is mu equal to 100. Would you agree with me? So far so good. Yes, no?
Yes,
Yes,
sir.
sir.
Now, by observing this value, what else can I write? Tell me. Okay. Can I write like this? X bar minus 100 greater than, see, anyway we have to subtract the mean. Okay. So 1 not 1.5 minus 100, or
Yes, sir.
X bar minus 100 less than 98.5 minus 100. Can I do? Right?
Yes, sir.
I can do, right? Now the next task is, see what you can use a small trick here. The very few things, like if this is the two-tail test, right? What will be your test statistics? Then you will reject your H naught. You will reject your H naught if absolute difference of X bar minus mu is greater than some C. Yes or no?
Yes, sir.
And this is the in this form you have to bring, right? Now my X bar is greater than 1 not 1.5 and X bar is less than 98.5. So I have to bring in this form. Then what I will do? Okay, what is the meaning of this? First of all, X bar minus mu greater than some C, or X bar minus mu less than minus C. This part we have to bring, right?
C is 1.5.
So correct. So that's what I'm trying to say here. So I can write X bar minus 100. So why I subtract 100? Because mu is 100. This will be greater than 1.5, or X bar minus 100 less than minus 1.5, given that mu is equal to 100. So far so good. Now,
Yes.
what else I can write? Can I write probability the absolute difference between X bar minus 100 greater than 1.5? So
Yes,
far
sir.
so good. Now what you have to do? What
Sir,
if X?
two times, na? Because you
Okay,
are
why 2 times? I have wrote this form only.
Bar is
Okay.
included.
Now the next task is to convert in standard normal form. What I can do? So if you see, if X follows normal 100 comma 4, then what will be X bar? Normal 100 comma 4 divided by 9. It's a sigma square by n. So it will be, what I have to do? X bar minus 100 divided by square root of 4 by 9, that is 2 by 3, greater than 1.5 divided by 2 by 3. Okay, and see, mu is equal to 100 we have already used. So this will be probability absolute difference of Z greater than, what is the value of this 1.5 divided by 2 by 3?
2.25.
Someone is speaking, voice is very low. 2.25, right? Okay, I'm assuming this is the correct answer.
Yes, sir.
Now, I'm just skipping this step. Can I write 2 times of probability Z less than minus 2.25? The same procedure, you can write this part, I'm just from the above question, Z greater than 2.25 or Z less than minus 2.25, and this part I can write probability Z less than minus 2.25 plus probability, this part again, Z less than minus 2.25. This will give you this part. Okay? Yes? No? Any doubt? So this part, what is this? I can write FZ of minus 2.25, and I think this value is given to us. Yeah, 0.012. So this will be 2 into 0.012. That means 0.0244. This is your answer. Is this clear?
Sir, can we divide by the standard deviation in the line in which you have written X bar is minus 100 is less than minus 1.5?
Yeah,
And
you can do here only. That's not a problem. Then you have to do like this: 2 by 3, 2 by 3, 2 by 3, 2 by 3. Mathematically, it's correct. That's not a problem. Okay. I didn't divide it by standard deviation just to give you the idea of this absolute difference between X bar minus mu. Okay. You can see now what this form is: X bar minus mu greater than C. Okay.
Okay, sir.
Okay, great. Then move to the next question. Yeah, this is the solution part. So next question is, information is same. You have to find the power of the test. What is the power of test? That is 1 minus beta, which is defined as probability of rejecting H naught when H naught is false, right? Basically, 1 minus beta is what? What is the power? Means you are rejecting that item When atom is of bad quality, right, this power should be high also. So just calculate the power of the test for this question. Okay. So I'm going to give you again 3 minutes. Please do let me know if you need extra time. Okay. Do you need extra time limit? Anyone?
Yes.
1 minute, 3 minutes.
3 minutes.
1 minute.
Hello, sir.
Yes.
F, Z value is not given there.
It means you have to use the previous one, maybe.
I don't think so because 103 different is same, not same.
No,
In,
first of all, you
in that
first of all just
accept,
solve this, right? Then you can comment whether it is useful or not. Okay.
is the acceptance reason will be the same? Will the
Everything is
acceptance
same.
reason same?
Correct. Correct. Every
Yes.
information is same. Here, no need,
But
no. There is no
hypothesis
use of
here.
acceptance reason. It's use of rejection reason. Okay. Everything is same. What you have to do, you have to find the power of the test. Okay. Every information is same.
So
Just
sir, we need C. We need C to check the power of the test.
sorry. I
Or
think
we
your
we
voice
have
is a
to
bit low. Can you speak a bit loud, or else I think your mic is too far. It seems. See
sir,
the what
we have to calculate C here.
No,
with
what's
respect
the
to
what
1.
the need of C here? What's the use of C here? You have to calculate the power of the test only. 1 minus beta. Okay. And you have to identify what is the C. See, in the last question, we found, right, C is 1.5. We didn't calculate separately.
Okay. Okay.
Okay.
Got it.
Yeah. Okay.
Hello, sir.
But sir,
Hello, ma'am.
sir,
Hello.
acceptance reason will be changed in that case, I
Yes.
think so,
Hello. Yeah.
because of new
See.
change.
Okay. Okay. Just try your best. Okay. Just try your best for now. Okay. So the thing is, the same acceptance region is there. Every information is same. Okay. I mean, same acceptance region means same rejection region. Okay.
But the mu is changed, no?
That's what. See, mu is changed because what is the definition of power of the test? Tell me.
1 minus beta.
Okay.
That will be reject H naught given
Okay.
H alternative is true.
Alternative is true. And what is this? What this is not null. See, mu is equal to 100 is for what? Null, right? And alternative says mu is not equal to true. Mu is not equal to 100. Now in the question you can see it's given alternative, not right. So mu has been changed. So it says you to use here mu is equal to 103. Use the same rejection region. Use the same test statistics. Rather than 100, you to do subtract 103.
When we will subtract the reason 101 and 9.98.5, then the value will not be same with respect to 103.
See, if it is not same, just try your best, right? That's what I'm saying. If it's not same, just think a bit more, okay? Just do your
But
best.
that's why I'm telling, I'm asking for a Z value for
See, if
4.5 and 1.5.
listen to me. If that value is not given to me, that means you have to apply some concept, something you have to think a bit, okay?
Okay. Okay.
Just try to solve this.
So can you give 1 more minute, sir?
Okay.
Sir, one small question, sir.
Mhm.
So this is regarding one of the previous weeks, sir. I just had a clarification, sir. When we do the double integral, for a uniform distribution in a joint distribution of two continuous variables, and when it's uniform, if we want to find out the double integral, can we first do with respect to y, then with x, or can we do
Anything.
we can do both, no, sir? First
Yes,
x,
sir.
then y, then first y, then x.
Yes.
All right, sir. Just wanted to clarify that. Sir. Thank you, sir.
Okay. Anybody else? You need extra time limit?
No, sir.
It seems most of you are not trying. I don't know why. Only I got 3 responses from your end. This seems wrong. This seems wrong because power of the test means power of the test would be high. Okay, let's try to discuss. Okay. So what is the beta? Sorry, 1 minus beta. 1 minus beta is probability of rejecting H naught when H is true. When you will reject H naught? So in the last question we say we had a acceptance region, right? So rejection region we decided X bar should be greater than 1 not 1.5 or X bar is less than 98.5, right? Given that alternative is we have to take mu as a 103, correct?
Yes.
So far so good.
Yes.
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 So what is your next task? Okay, if this is the case, can I write like this? Probability that X bar is greater than 1 not 1.5, given that mu is equal to 103, plus probability that X bar is less than 98.5, less given that mu is equal to 103.
Yes, sir.
Now, what is your next task? Your next task is to convert in standard normal variable. What else you can do? X bar minus mu. What is mu? Let's write like this. X bar minus mu divided by sigma by root 10, which was 2 by 3.
Yes, sir.
Greater than 101.5 minus mu divided by 2 by 3. Given that mu is equal to 103 plus probability that x bar minus mu divided by 2 by 3 less than 98.5 divided by 2 by 3, given that mu is equal to 103. Correct? Sorry, 98.5 minus mu. Yeah. Now it will be, now this part I can write as a z greater than 101.5 minus 103 divided by 2 by 3. Correct? Plus probability z less than 98.5 minus 103 divided by 2 by 3. Now what is this value?
That's I am asking, sir.
Don't worry, I will come to that point. Don't worry. One second. What is this value?
minus 1.5.
After dividing 2 by 3?
2.25. Minus 2.25.
What about this?
6.75. Minus 6.
6 point.
Okay. This value is not given. It's given z less than. So I have to convert 1 minus probability z less than minus 2.25. Can I write like this?
Yes, sir.
Plus probability z less than minus 6.75. Okay. And what is this? This is 1 minus fz of minus 2.25 plus fz of minus 6.75. First of all, what is this? 1 minus this value is given to us? 0.012.
Yes.
What about this part? I just wanted to just think a bit. What should be the value of this?
Hello, sir. You are not audible.
Hello, can you hear me?
Now yes.
What is the value of this part?
Three times of
2.25.
3 times of 0.012.
How?
No, sir, three times of 2.25.
Yeah.
Is it 0?
Correct. This is 0.
Okay, after.
See this part. If you see standard normal curve, this z covers from minus 3 to 3, right? If you see that, and this minus 3 to 3, probability that minus 3 to 3, I think it covers around 99 point something, right? If I can't recall the exact probability. See, after this, your probability is approximately 0. Okay.
Yes.
So this will be approximately 1 minus 0.012 plus 0. And this will be 1. What is the value of 1 minus 0.012?
0.998.
Something, right? Is this clear now?
Sir, could you please repeat once again this minus 3, 2 and 3 part?
See, if you see the standard normal curve, okay, if you see one standard sigma minus 1 to 1, right? How much percentage it covers?
6.68. I think, if I remember.
60 something. 6 something.
Yeah, just think a bit and tell me.
I think 0.
I think it's around 68%. Yes or no? And what about 2 sigma?
0.999.
No. For 2 sigma, I don't think it's 0.3. It's a 95%.
Okay, 95%.
So basically, it says for 68, 95, 99.7 rule. So this is when your z will lie or x will lie within 1 standard deviation. This is within 2 standard deviation. This is percentage of 3 standard deviation. After 3, it will be approximately 0. Okay?
Yes.
Is this clear?
Yeah, in the table also they show from minus 3.9 to 3.
Correct. Okay? I hope this is clear to all of you, right?
Yes, sir.
Excuse me, sir.
Yes.
Sir, but here beta should be except H naught by HA.
This is not beta. We are dealing with 1 minus beta.
That is 1 minus reject.
1 minus
Correct.
beta.
Okay.
Okay.
Sir, this is PYQ questions.
So I don't think I should give the answer of this question. So next question is a commonly prescribed drug for relieving nervous tension is believed to be only 40% effective. To determine if a new drug is superior in providing relief, suppose that 100 people who are suffering with nervous tension are chosen at random and inoculated. If more than 50 of them are found to be relieved, we reject the null hypothesis that P is equal to 0.4 and the new drug will be considered superior to the one currently in use. So what do you mean by superior part? How will you define your hypothesis?
The P is equal to 0.4.
P is equal to
0.4.
This is null hypothesis. What about alternative?
Not equal to
Greater
0.
than 0.4.
Greater than 0.
0.4.
It's a not. It's a greater than. It is say it's a superior, right? Okay. Now you have to use the binomial, normal approximation to binomial. First of all, you have to. What will be your success? Whether drug is basically effective or not effective, means that is providing relief or not. Okay. And you have to apply the normal approximation. Okay. So we know by the central limit theorem for a large sample, what is the case? Every distribution will follow the normal distribution. Okay. So for this 100 people, okay, if this 100 people will follow normal, what will be the mean? You have to decide with n into p, and what will the variance? You have to decide with that. Okay. So you have to calculate probability of type 1 error as well as probability of type 2 error. Okay. So I'm going to give you 3 minutes for this question. Okay. Please attempt it.
Okay, sir.
Sir, in this question, first of all, we have to give the answer of type 1 or type 2 both.
Both.
Hello, sir. Hello, sir.
Yes.
Sir, I cannot found the value of C here.
It's given that in the question only. Just read the part. Then what will be your hypothesis here? I mean, what will be your test?
P is equal to 0.4.
No, I'm talking about test. When you test means what? How will you decide your test? Means when you will reject your H
Reject.
naught.
reject H naught.
Yeah, when?
Reject H naught. If given P is equal to 0.4 into 100. That is
Your
40.
voice is breaking. Your voice is breaking.
So can you
Okay,
give
do you need
three?
extra time limit?
Yes, sir. Yes, sir. 3 more minutes. Sir.
Oh, okay. So anybody, do you need extra time limit?
Sir, type 2 is calculating, sir. Just wait.
So let me give you 1 more minute and then we'll start. Okay. So should I discuss the solution or is it do you want to try?
Sir, first one is calculated, second one is still calculating.
Okay, no problem. Let me solve this because we have to discuss some more questions. Okay, I think from it you have another session also, right?
Yes, sir.
Yeah, that's why. Okay, so by seeing the question, so what you have to test whether the drug, I mean the new drug is superior or not. Okay, so this means what? What is your H naught? So if you
P is
see,
equals to 0.4.
correct. So P is equal to 0.4. So you have to check whether drug is superior or not. So that alternative will be P is greater than this 0.4 or not. I mean, superior means your as per your claim. What is value of C? This is 50, right? Because it says if more than 50 of them are found to be relieved, we are going to reject the null hypothesis. See, if according to this, okay, suppose let me tell you very simple scenario. If mu is greater than some value, let's say mu dash, then what will be your test? Test will be you will reject your H naught if X bar is greater than C. Yes or no? Yes, no?
So this is basically the threshold value, right, sir?
Threshold value, correct. So
30.
what is this threshold? So this is says if more than 50 of them are found to be relieved, we will reject the null hypothesis, right? Okay. So my C is 50. Okay. And what is by test statistic? First of all, this test statistic, this is following, let's say the test statistic is, what if this follows, first of all? This will follow binomial. Yes or no? And n comma p. What is n? We are going to test on 100 people, and what is the p? Correct. But for this, okay, if you will apply the central limit theorem, it will follow the normal distribution. Yes or no? Suppose
Yes, sir.
Yes.
we have t statistic. What will be the mean? Mean is np. In case of binomial, right? So mean will be 100 times p. Forget about 40. We will substitute the later. We will let's do in general here. 100 comma p, 100 into p, and what is the variance? 100 into p into 1 minus p. Is this clear or not?
Yes.
Yes, sir. Clear.
Yes, sir.
Right. Now, when you will reject your H naught, so my test is, I am going to reject my H naught if my test statistic is greater than some C or not. So in the question itself, it is given that I will reject when T is greater than 50. So far, so good.
Yes.
Okay. Is the question clear now? Now, the next part is, it is asking alpha. I mean, that is probability of type 1 error. What is the type 1 error probability? That rejecting H naught when H naught is true. So rejecting H naught. So when you will reject H naught? Tell me.
When T is greater
Than 50.
Greater than C.
Greater than 50, yeah. So P is equal to 0.4. Yes or no? And what you have to do next task is we have to convert it in standard normal form. So this will be T minus 100 into P divided by square root of 100 P 1 minus P greater than 50 minus 100 P divided by square root of 100 P 1 minus P, given that P is equal to 0.4. Would you agree with me, all of you?
Yes.
Now, it will be probability that this will be G greater than 50 minus, if you substitute P as 0.4, it will be 40, right? 100 into 0.4, that is 40. So 50 minus, okay, let me substitute the values anyway. 0.4. Anyone can just calculate this value and let me know. So this will be 0.4 and 0.6. So this probability.
It will be, sir, 50 minus 40 by root under of 24.
What is the final value?
The final value is, sir, 2.04.
2.04. Now can I write 1 minus probability Z less than or equal to 2.04 just to convert in FZ form? So it will be 1 minus FZ of 2.04. So I think this value is given to us in the question 0.979. So 1 minus 0.979.
0.021.
0.021. This is alpha. I mean probability that type 1 error. Now next task is we have to calculate the probability of type 2 error. And what is the probability of type 2 error? We know probability of accept H naught when HA is true. And in the question it is given that we have to find the probability of type 2 error when P is equal to 0.6, right? Because we are dealing with HA. In the question it says P is greater than 0.4. So we have to substitute some particular value. So here it will be when you will accept as your H naught first of all. So here you are rejecting your H naught when t is greater than 50. You will accept the H naught when t is
less than 50.
less than or equal to 50, and we have to substitute the value p is equal to h.6, and the same procedure we have to do again. Converting standard normal to it will be, I'm just writing directly g less than or equal to, I should write 50 minus 100 times p divided by square root of 100 p 1 minus p, given that p is equal to 0.6, and it will be probability g less than 50 minus it will be 60, and divide by square root of 100 into 0.6 into 0.4. Anyone, what is the calculation?
24.
Yes, sir.
Root 24.
No, I'm not asking inside the root. I'm just whole.
It will be minus 2, minus 2.04.
Minus 2.04.
Yes, sir.
I think this value is given to us. No, so
But sir, I can reach until this step, but after all, I can't do that.
1
see,
minus
probability z is less or equal to 2.04. Can I write 1 minus probability z greater than so no.
Less than equal to 2.04.
No, not 1 minus.
Sir, minus sign is given. That's the problem.
See, not this is not a problem. Can I write this is a probability z greater or equal to 2.04? If you see the standard normal curve, so something value less than minus a, this is same as something value z greater than a. So this less than minus 2.04, this is same as probability z is greater than 2.04. Yes or no? Now, can I write 1 minus probability z less or equal to 2.04?
Yes.
Alpha beta would be the same.
Correct. Alpha beta will be the same. Now here 1 minus 2.04. So this is fz of
function of z.
And 1 minus 0.797. Again, same value, right? Okay. Is this clear now? Yeah, same. Okay. Well, so any doubt in the previous one?
No, sir.
Okay. Now, if you see the question number 4, so the proportion of adults living in a small town who are college graduates is estimated to be p is equal to 0.4. To test this hypothesis against the alternative is given to you as p is greater than 0.4, you have to decide to take a sample of adults from the town. Now, your main question is, what sample size do you need for a test against the alternative hypothesis p is equal to 0.6 at a significance level of 5% and power 95%? This means you have to calculate the value of n, and for this, you have to use a significance level of 5%, which is alpha, and you have to use the power 1 minus beta, which is 95%. So you have to make two equations with the help of alpha and with the help of 1 minus beta, and then you have to find the value of c from those equations. Are you getting my point? So usually we are doing, right? If you see in the questions, what usually do in the very first question, so we are calculating the value of c, right? With if alpha is given to you, you will find the value of c, and then you will decide whether to reject or accept, right? Similarly, you will proceed with the 1 minus beta because power is given to you, and you will calculate the value of c something, and then you will equate, and then you will find the value of sample size, which is n. So I'm going to give you 3 minutes. Please do let me know if you need extra time. Okay. Okay, so 3 minutes.
Yes, sir.
Sir, done.
Okay, so well, anybody? Do you need extra time limit or should we go ahead?
So we should go ahead.
So give
So is
one
this
more minute, sir.
1 minute?
1 minute, yeah.
Okay, okay, no problem.
Sir, we can't edit our answers, sir.
Yes, you can. No problem. Whatever the solution we will discuss, just try to match. So that's not a problem. Okay, so let me discuss the solution part. So, so there are two questions. First, we have to find the n, and once we find the n, we have to find the value of c. That's not a problem at all. So, what is the p? I mean, what is the h naught? So, if you see in the question itself, so h naught is p is equal to 0.4, and what is the alternative? P is greater than 0.4, right? And we have been given alpha is 5% and beta 1 minus beta is 95%. That means we have to use these two information, right? What is our test statistic first of all? Tell me. Let's say T. T is binomial 100 comma P. And if I'll talk about to normal approximation, then this will be normal with 100 into P comma 100 P into 1 minus P. Would you agree with me?
Yes.
Now let's do something else. I mean, let's do something like this. Suppose I'm saying X bar. If X bar, then what is the distribution of X bar here?
It will be same.
No, it not. If X follows normal mu comma sigma square, then distribution of X bar is normal mu comma sigma square by n. Right?
Yes, sir.
So what is the expected value of here? What will be the expected value of X bar here?
Sir, in this, we have to find the n.
In this case, same. It would be the same. 100p and 100p 1 minus p.
No, you are not getting my question. Okay, let's try to do like this.
It will be p into 1 minus p, sir. The variance, the sigma square will be p into 1 minus p, right?
No. P into 1 minus p. No. Can you think of it again?
Sir, because test statistics is here sample mean.
So 100p into 1 minus p divided by n.
No, not see that you are not thinking about. Just think a bit. See, okay, forget about this normal 100p comma 1 minus 100p comma 100p into 1 minus p. Okay. See, how many people are there in the? It is asking about 100 people, right? No, sorry, n is not given to us. So let's say I'm talking about in general. If that is the case, okay. Let's type like this.
Sorry, sir.
So,
Sir, is it p into 1 minus p divided by n?
Correct. That's what I wanted to listen. See, let's write to like this. So if for each xi, it will be by Bernoulli, right? For each xi, it will be Bernoulli or not, right? Suppose there is x1 up to xn. Okay, if each xi is Bernoulli, so let's say I'm talking about c x bar. So this will be normal, and it will be mu. And what is the mu for each Bernoulli? See, x bar is what? X1 plus x2 plus so on xn divided by n, right? If you just think a bit, if you calculate the expected value of x bar, it will be p plus p plus p plus p, n times p divided by n. So n will get cancelled out. You will get p. Are you getting my point? Yes. What is the variance in case of Bernoulli distribution?
P into 1 minus p.
P into 1 minus p. So it will be p into 1 minus p plus p into 1 minus p, basically divided by n times p into 1 minus p, and this will be n square. So this will be p into 1 minus p divided by n. Would you agree with me now? Yes? No?
Yes, sir. Yes, sir.
Is this clear to all of you?
Yes, sir.
Okay. Now, what will be your test as per the hypothesis? I will reject my H0 when? If? Tell me. This is your test statistic. When you will reject your H0? See, by the hypothesis only you can decide. When you will reject your H0? If?
When p is greater than 0.4.
Sorry?
X bar greater than C.
Correct. So your X bar, your sample mean is greater than some critical value. Right? Are you getting my point? So this X bar is what? This is your sample statistics, right? See, I'm doing in this question in a different way. You can do in 100, you can do like this, 100p, 100p into 1 minus p. I'm doing in this way because of the same, in similar way we did here. See, you can again do the same thing here. X bar follows normal p, p into 1 minus p divided by 100. Yes or no? The same thing you can do here, because you are going to consider each exercise, whether for each exercise Bernoulli, whether drug is effective or not. I mean, drug by using that drug, whether it's really giving relief or not, right? Are you getting? Yes. No?
Yes.
Let's see. You can speak as something. Only then I will be able to know whether you are getting or not. Okay. So what is the alpha? Alpha is probability of rejecting H naught when H naught is true. What is this? X bar is greater than some C. Okay. Given that P is equal to 0.4. Okay. Then probability. What is the now? What you have to do? You know, this is the case statistics. What you have to do? I have to subtract the mean, which is P, and divide by square root of variance. Yes or no? Greater than C minus P, divide by square root of P into 1 minus P divided by N, given that P is equal to 0.4. Is this clear to all of you?
Yes, sir.
This will be G greater than C minus 0.4 divided by square root of, so it will be 0.4 into 0.6, that is 0.24 divided by N, right? And alpha is 0.05, 5% is given to us. So this will be 0.05 is equal to, can I write? This is 1 minus probability Z less or equal to C minus 0.4 divided by square root of 0.24 divided by N. Yes or no? Usual procedure. Correct? Are you getting, everyone is getting this part, or I'm just blindly speaking?
Yes, sir. Yes, sir.
Okay. Now, so this is 0.05. This is 1 minus. Can I write this fz of C minus 0.4 divided by square root of 0.24 divided by N?
Yes.
Right?
Yes.
Now, from this, what else can I write? Can I write fz of C minus 0.4 divided by square root of 0.24 divided by N? And this will be 1 minus 0.5, which is 1 minus 0.95. Right? Now, what else can I write? Just basic mathematics here. So, C minus 0.4 divided by square root of 0.24 divided by N equal to fz inverse of 0.95. Yes or no?
Yes, sir.
And what else can I write? I can write C as a, it will be square root of 0.24 divided by N into fz inverse of 0.95. Yes or no? And 0.4 plus. Correct? Are you getting?
Yes, sir.
So let's make it equation number 1. Okay. Now we will use the same thing, same procedure. We will do the same procedure for 1 minus beta. What is the 1 minus beta? Probability of rejecting H naught when HA is true. So it has been given in the question. We have to take for HA as a P equal to 0.6. So it will be X bar greater than C, given that P is equal to 0.6. Everyone is getting this part? So can I skip some steps here? The same procedure. So this will be Z greater than C minus 0.6. Do let me know if whether you are getting or not. And divide by 0.24 divided by N. Is this clear to all of you?
Yes, yes, sir.
Right?
Yeah.
Now, 1 minus beta is given to us 0.95. Now from here, what else can I write? To convert in FZ form, I should write 1 minus probability Z less or equal to C minus 0.6 divided by square root of 0.24 divided by N. Would you agree with me? This part can I write probability Z less or equal to C minus 0.6 divided by square root of 0.24 divided by N equal to 1 minus 0.95, which is 0.05. Now from here, what else can I write? Tell me, can I write this as fz of C minus 0.6 divided by square root of 0.24 divided by N as 0.05? From here, what else can I write? C minus 0.6 divided by square root of 0.24 divided by N as a fz inverse of 0.05. Correct? Now, from here, so simply I can write 0.6 plus square root of 0.24 divided by N into fz inverse of 0.05. Yes or no?
Yes.
So what we have to do basically, see this value is given to us in the question, and fz of fz inverse of 0.95 is also given. Basically fz inverse of 0.95 will be 1.64 and fz inverse of 0.05 will be minus 1.64. Are you getting? So basically, can we equate equation number 1 and 2? Let's say this is 2. So what we will get from equation number 1, this is 0.4 plus this whole part. So basically it's 0.4 plus square root of 0.24 divided by n, fz inverse of 0.95. This is equal to 0.6 plus 0.24 divided by n, fz inverse of 0.05. Okay, is this clear to all of you?
Yes.
So what you have to do, you have to substitute the value here, you have to substitute this value here, and you can see there is only one unknown quantity, which is n, right? Basically it will be 0.4 plus square root of 0.24 divided by n, and this fz inverse of 0.95 will be 1.64, and this will be 0.6 plus square root of 0.24 divided by n, and this will be minus 1.64. And just solve this question, equation, you will get the value of n. Okay, and it is asking in the next part, what is the value of critical value? When you can find the critical value, if you can substitute value of n here, you will get the value of c or not,
Yes.
from
Yes.
either in equation 1 or equation 2. Okay, so I'm not solving those part because we have limited time. So what is the value of n? Let's check. So n is 65. Okay, n is approximately 65, and the value of c you will get 0.49. Okay, is the idea clear? Yes or no?
Excuse me, sir.
Yes.
Sir, in this solving 1 and 2 equation, how is it that in the PDF which you are showing solution,
how
in
is
that
it?
2 multiply by 1, 2 multiply 1.64 in the second
That's what
line.
you have to think of it. See, tell me, this part is going to be same or not? Here
Okay.
you will get minus of this. If you substitute here left side, it will be 2 times of this part.
Okay, got it, sir.
Just a basic mathematics. Okay. Okay, so the very last question is a survey of 200 randomly selected students from a school revealed that 70% of them participates in extracurricular activities in this school. So main question is, can we conclude at 5% level of significance that 80% of the students participate in the extracurricular activities? Okay, so first of all, okay, so would you like to solve or should I solve as per the time? Should I solve? If you want, I can allot the time. We can extend the session for some time. That's not a problem. Would you like to proceed? Yes, no, anything.
So how many questions are left, sir?
This is the last question.
You can solve, sir.
So you quickly solve.
Yes, sir.
Okay, you don't want to try?
But time is less actually. Class is about to start.
Yes.
Okay, okay. Okay, then you have to tell me and I will start. Okay, what is the, okay, tell me what are the part, what are the things we have been given in the question? Sample size is 200. Okay. Now, what is the level of significance? It's clear, so 0.05. What is the H naught? Tell me H naught. What should be
H naught is 0.7.
Just think a bit again. Whenever you are defining H naught and null hypothesis, alternative hypothesis, it's always about your parameter. It's always about parameter means, I mean, parameters of the population. It's always about mu sigma square, not x bar. Are you getting my point?
Yes, sir.
Because you are making the claim about population based on the sample you are going to test. So P will be
0.8.
0.8. No, not 75. See, this 75 is based on this 200 sample, right? Randomly selected student, right? See,
That's a study.
and what is your correct? What is your claim? Claim is 80% of the student participate in the extracurricular activity, right? You have to check this. So P is equal to 0.8. Since this is not, there is nothing mentioned clearly whether it's greater or less, I will take P is not equal to 0.8%. Correct?
Correct.
Now, if you see each xi, see x1 up to x200 will be Bernoulli, because each xi is whether he will follow in extra activity or not, right? Yes or no?
Correct.
That's only two possibility, right? Just now we in the previous question we saw what will be the distribution of x bar then? It will be normal. What is the mean? Mean will be p.
P.
Variance will be p into 1 minus p divided by 200. Yes or no? Do you agree with me?
Right, sir.
Now, what will be your test? Tell me. Test is what? You will reject your h naught if, tell me,
Mod
this
of,
is two-sided test.
sir, yes.
This means
Yes, sir.
mod of x bar minus p is greater than some c.
Correct.
Yes, sir.
Yes or no? Now, so we will proceed with alpha. So alpha is probability of rejecting h naught when h naught is true. So 0.05 is, this will be absolute difference x bar minus p greater than some c, and p is equal to 0.8, right? Now this will be, see, if you see from here, what we have to subtract, we have to, there is no need to subtract p, right, to convert in standard normal form. What we have to do? Basically, we have to divide by
Sigma
square
by
root of p into 1 minus p divided by 200, right? And
C by.
should I subtract c minus something or not?
No, no, no.
No need, right? And
Yes.
it will be p 1 minus p divided by 200, and this will be probability z greater than c divided by, it will be 0.8 into 0.2, so that will be basically 0.16. What is the value? Anyone can calculate this quickly and tell me the values? Or should I do directly?
You can do
Okay,
directly.
basically, it's a, see, 0.8, 0.2, 0.16. So this will be 0.16 divided by 200. So basically, it will you will get a square root of 2 divided by 50, if I'm not wrong. You can check. See, so this will be probability. So this is mod. Okay. Mod z greater than, at the end you will get minus 50 divided by c. Sorry. 1 second.
Root 50.
Yeah, 50 divided by c, square root of 2, right?
Correct. Yes.
Correct. Now this part, if you convert this, it will be probability z greater than 50c divided by square root of 2, or z less than minus 50c divided by square root of 2. Correct. So let's go with the anyone, that's not problem. At the end, you if you are going with this probability z greater than 50c divided by square root of 2, at the end you have to convert 1 minus. Okay, so at the end you will get the same value. I am doing directly 2 times
Sir,
of,
I think it will be root 50 c by 2, right, sir? Root 50 c.
root 50, no, right?
0. Okay. I don't. I think I have done a mistake, sir. Sorry.
Yeah.
Please carry on.
No problem. So this is 0.05. So this will be 0.05 divided by 2. This part I can write fz of minus 50 times c divided by square root of 2. Okay. So this is nothing but 0.025 equal to fz of minus 50c divided by square root of 2. I think, yeah. So you can see minus 1.96 is there, right? So this fz of minus 1.96, this is same as fz of minus 50c divided by square root of 2. So from here we can find minus 1.6 as a minus 50c square root of 2, and we can calculate the value of c. So c will be basically let me calculate it. So this is square root of 5 divided by 50.
So 1.96 into root 2 by
0.05. So this will be 0.05. So when I will reject, when absolute difference of x bar minus p should be greater than c. What is the x bar? It's 70% given in the question. Minus what is the p? 80%. So absolute difference will be 0.10, which is greater than 0.05. This c. Yes or no? So this means what? You
Sir,
will
please explain mod x minus p.
mod x minus, see, what is your test? So test is, I'm going to reject h naught if mod of x bar minus p is greater than c. So x bar is given in the question 0.7 and p is 0.8. So this would be greater than c. C is 0.05. So 0.1 is greater than 0.05. So I will reject my h naught. Okay.
Okay, sir.
So okay, so that's all about today's slides. Okay. Yes.
Sir,
Huh.
sir, I have a doubt in the course grading. So, sir, can I ask now?
Course grading. What is your doubt in course grading?
Sir, my doubt is that, sir, in the graded documents, it is told that the week 12 graded assignment will not be considered for grading, but it will be used for the final scoring. So, sir,
Correct.
how is it going to happen? That's what I'm asking.
No, no. The very basic thing is, uh, sorry, yeah. So this means for GA evaluation, week 12 will not be considered. Okay. Means see, usually if you see the grading documents clearly, for NTEM eligibility and all,
Yes, sir.
they are taking some best 10,
Yes,
best
sir.
7, something like that, right? For
Yes, sir.
GA,
It is given that.
or
Yes, sir.
GAA, they are taking some week first 10 or something, average of 10, something
Yes,
like
sir.
this,
The
right?
average of first 10, yes, sir. The
Correct.
average of first 10 weeks will be used for the final scoring.
Correct. But they will not take week 12 under any evaluation. But main thing is it will be in the syllabus of NTERM. Means you have to see. Do not think there will not be any GA evaluation for week 12. Then no need to study the week 12. No. The only opportunity is the only facility is there is no need to do the week 12 GA, but you have to study properly because it is going to come in your NTERM exam.
Sir,
Okay.
the session is over, right? We
Yeah,
can give.
session is over. Yeah, session is. So we are done with the. Uh,
Sir, what is the passing marks of NTEM?
I think that this kind of ops work you can discuss with the support team. You can mail to them. Okay.
It's given in the grading documents. You can check over there.
Correct. Just check your grading document. Just check your student handbook. Right. Do something.
Okay. Thank you, sir.
Okay. All right then. Thanks all. Bye.
Sir, excuse me. Sir. Hello.
Yeah. Go
Sir.
ahead.
Sir, I am telling you, sir, then can I skip the graded assignments of week 11 and week 12 because, sir, I have exams of my first semester in my college.
That's your responsibility. I think you have to take your decision. If you feel see grading in grading document in GA they are taking best 10, right, or something
Yes,
like
sir.
that.
First 10 weeks. Yes, sir. As the average score of first 10 weeks are being taken, so that's why I'm asking that can I
So
skip the week?
it's your decision. So it's your decision whether you
Sir,
want
then
to
it will
skip.
not. Sir, then it will not affect the marks side because, sir, as I got eye problem, that's why doctor told me to take rest for some days, and now I have practical of my first semester in the 3rd of April. That's why I'm asking. So that's why
Okay,
can I
let me
skip?
see. Let me be very clear. So if you see the grading document, right? So in grading
Yes.
document, it is clearly mentioned they will take average score in first 10 weekly graded
Yes.
assignments, right? So first 10 means what, right? So maybe you have skipped some assignment in between. Then it will be considered till week 11, something like that. Okay. So just consider those part, and it's your decision whether you are submitting or not. Okay. But
Okay,
week
sir.
12 will not be included in GAA. See, week 11 will be included in your GAA. Suppose you have missed week 12, week 2, something like that. Okay. For example,
Okay.
then out of 11, if you miss the week 2, it will be considered as 10. Okay. I mean, for more clarification, you can mail to support team. They are the correct person for that. Okay.
Okay, sir. Okay.
Okay.
सर
Okay. Thank you, sir. Thank you, sir.
सर ग्रेडिंग डॉक्यूमेंट में दो तरीके से एंटम का मार्क्स ऐड किया जाता है बट आपने बोला था कि फर्स्ट सेमेस्टर एंटम में 40 से ज़्यादा आना चाहिए ऐसा आपने बोला था फर्स्ट सेमेस्टर में
Sir,
लेकिन
for
ग्रेडिंग डॉक्यूमेंट
to pass exam, it's 40%.
यस सर इट इज़ कंपल्सरी टू गेट अबव 40% मार्क्स इन एंटम
Correct. Only then you will get a good marks. Okay.
यस सर थैंक यू सर
Oh,
Excuse me, sir. Sir, I am not eligible to take the maths and term exam, so I have to repeat the one and term.
Again, my answer is going to be same. Please
Only one term.
contact the support team. They are the correct person for this kind of.
Sir, I have to repeat the one term only.
That's what I'm saying, Neha. Support team is the correct person for this kind of questions. Okay. They will answer you. Okay.
Okay.
Okay. Okay, thanks all. Bye.
Thank you, sir.
Thank you.